What does it say we're talking about today? Line segments. Okay, everybody ready? Ready? So the first blanks we're going to fill in say a line segment is a measurable part of a line. That means a specific length, okay? That consists of 2 points that are called end points. Okay? 2 points that are end points. There's a big difference in the way we draw a line segment versus the way we draw a line. What did we say yesterday lines had on the ends of it? Arrows. What are these, this line segment, what does it have on the ends? Points, okay? These are my 2 end points. Okay, here's a question I'm going to ask, and it's going to be on your quiz, and we don't want to get confused with it. Because these are my 2 end points, are those the only points on that line? No, okay. So when I ask the question on the quiz, how many points are on a line segment, you're not going to tell me 2, are you? Okay. But if I ask you how many end points are on a line segment, you're going to tell me 2. Just don't want to get ahead of myself. Let me just read a little bit because I want to tell you something, but I don't know if that's written somewhere else. Yes. That little green thing right there looks like a robot. When you do that, just stick your pencil in and let it go. It will sharpen it and it'll push it back up when it's done. Good. Okay. So what I want to talk about before we move on to this is one of the questions I'm going to ask you on the quiz is how many points are on a line segment. Okay, so let's do this. Let's say this is 0 and this is 1 on the number line, right? What's halfway in between that? 0.5. Could I go halfway in between 0 and 0.5? Yeah. Okay. Don't really know what that is, right? 1/4 maybe? 0.25? Mm-hmm. Could I go halfway in between there? Yeah. Okay. Could I go halfway in between there? Could I continue to go halfway and halfway and halfway? Will I ever run out of points? No, because we talked yesterday, we said points have no size or shape, right? So when I ask you how many points are on a line segment, you're going to tell me infinite. So you might want to make that little note out there because that is a question. A line segment has an infinite number of points. Okay, that's just a little note because I know, ooh, that did not spell that correctly. I know that I will be asking that question on the quiz next week. I will ask you how many end points a line segment has. 2. And then I will also ask you how many points does a line segment have. And that's infinite. Everybody okay with that? Now, what it says is it has the 2 endpoints and then all of the points between them, which is we just talked about. The 2 endpoints are how we name our line segment. So, for example, this one would be called line segment AB, and the difference in the way we do that is we just put a bar with no arrows. Okay, that's the difference between a line and a line segment. If I wanted to call it line AB, I would put my line symbol up there. Okay. So the details are very important. If you tell me this and you're naming a line segment, I'm going to have to take points off because that's not a line segment, that's a line. Would it be okay, though, if I switch those around and called it line segment BA? Am I talking about the same one? Yeah. Okay. So just like a line, we can switch the order of the letters, but we just put the little bar over it. All right, the next part, it says, for any 2 real numbers, A and B, there are real numbers in between A and B such that A is the smallest, B is the largest, and everything in between. Okay, the relationship also applies to points on the line. And that is called the, I don't like this word, betweenness. spell it right, of points. Basically, meaning what we talked about. There's an infinite number of points in between any 2 points on a number line. Okay. But in between this, they're in between those two. That is probably not something I'm going to ask you about, okay, but we have to talk about it because it's in this section. But that's probably not a question I'm going to ask you about. Okay, the betweenness of points. Basically, this is what it says. If you're looking at that picture, point what is between A and B? Point C, okay? But what this concept says is the only way that C can be in between A and B is if they are what do you think? Collinear. Okay, that's what we're going to fill in there, collinear. And then also, we have segment AC. Do you ever see where I'm highlighting right here? Segment AC. Everybody see where I just highlighted in yellow? Mm-hmm. And then we have the smaller segment CB. And you have this statement here that says AC plus CB, the two small pieces, add together to give me a larger piece, AB. Which is going to lead us into the next segment addition thing. Okay. Here's segment AC. Here's segment CB. If I put those together, I get AC. AB, I mean. So AC, CB, putting them together makes a larger segment AB. Does that make sense? This is the segment addition postulate. I can take one segment. I can take another segment. I can add them together. And they just and then create a larger segment. In the same concept, I can give you a large segment, and I can give you the length of a small segment and ask you to find the other one, right? So, like, for example, if this is 10, the whole thing. If the black part's 2, what would the blue part be? 8, okay? Or I can do it the other way. If this is 3, and this is 4, together they would be 7. This is how we're going to use the segment addition postulate. It basically says, in the image to the right, point B. Whoa, that's not a pen, that's a highlighter. Sorry. Try that one more time. Point B is between points A and C. So therefore, again, we can say that we can take the two small segments, AB plus BC, and that will equal the entire segment AC. Okay, we just changed the letters around, but you get the idea. One small plus another small equals a large. And we're going to use this concept quite often. We're going to use it first to just find the length of segments, and then we'll use it later once we get into the famous proofs in geometry, but that's a little bit down the road. Okay. Is everybody following along? Okay. Everybody understand? Any questions? All right, in the image, line segment AB, how did I tell you had to write that? AB with what above it? A bar. Mm-hmm. What are the two end points of that segment? A and segment AB. A and B. It's like segment AB, what are my two end points? A and B. Mm-hmm. And what's in the middle of those? C. Okay. This is, I don't know, this is confusing. What? B is in the middle of there. Just scratch that part out. I don't like that. Just scratch that middle part out. Just scratch it out. Because they changed the letters around and it doesn't match that picture and it's confusing me. So let's rewrite it. AB, right? So in that picture, what are the two end points of my big segment? A and C. That's what y'all were trying to tell me in the first place. Yes? All right. And then my small segment AB, what's the other small segment? BC. And together they would give me AC. And that's exactly what this statement down here says that goes along with the picture. I don't know what that mess is that we just scratched out, but that's what I get for not proofreading my notes, huh? So, small segment AB plus small segment BC equals big segment AC. Here we go. You might want to grab a calculator. We're going to be doing some adding and subtracting, and specifically with decimals. So if you're not good at that and you want to grab a calculator, these are the examples we're going to do. Oh, I see. They're using the image above, not the one below. That's what it was. So what I want to point out is how things are worded. It's going to ask you to find the measure of segments, okay? So I want you to pay attention right here. Right here, it tells me to find the measure of XZ, and it's got the bar over it to let you know that that's a line segment. Does everybody see that? This is another way it could be written. It could just also say find XZ without the bar over it. If you ever see 2 points without the bar over it, and it's asking you to find that, that's asking you to find the length of that segment. Does that make a little bit of sense? So if they leave that bar off, they're talking about how long that segment is. Okay. So what I want you to do in that first example is tell me how long segment XZ is. How'd you figure that? Mm-hmm. So XY is one of my small segments. That's 11.3, correct? And then YZ is the other small segment. What is that one? 3.8. And so to find the big one, I would just do what to those numbers? Add them, and we get 15.1. Does that make sense? So when I write this, that means I want to know what the length is. Okay, so without the bar means how long is it? So I'll either write find the measure of with the bar on it, or I'll just say find without the bar, and that means find the length. Same thing, yeah. It's just 2 different ways to write it. That's what's so confusing with geometries. There's so many different ways to write things. You just have to be careful with that. All right, find QR in the next one. Be careful here. Let me ask you this. Does everybody understand what this means right here with these little bars and the arrows? Does everybody understand that that means that whole piece is that number? Okay. I just want to make sure you understand that. So I want you to find out what QR is. Anybody have any ideas? 7? 7? Is that what you said? 7? How'd you get 7? Yep, 13 minus 6. Big one minus small one gives me the other small one, which is 7. Yes. All right, try the next one. See how they just kind of change the pictures around, but they give you kind of the same sort of information, same process here. For some reason, sometimes segment addition is confusing to people. Just pay attention to what it gives you, where your numbers are. Is it giving you the whole big segment and asking you to find a small segment? Then you're going to subtract. If it's giving you the 2 small ones and it wants you to find the big one, you're going to add. Am I going to subtract or add in this picture? Subtract. I'm going to do 24.3 minus, and we get 6.5? Oh, did it say round? Oh, round to there's 10th. That's 1 decimal place. Okay, when you do the subtracting, always do the bigger minus the smaller. I think you probably did this. You did the top minus the bottom. Just do the bigger number minus the smaller. Ooh. That next question is a little tricky. Read it first. Just read what it says. Then we're going to talk about what to do here. Sometimes in geometry, a lot of times, you're going to need to draw a picture to represent what they're describing. Okay? So first of all, just read what it says. And we want to see if we can draw a picture to represent it. We're finding the value of x and the length of BC. Do you see how it says BC with no bar over it? That means the length of BC. If B is between A and C, so the first thing I want you to do is draw the picture of B being in between A and C. We're drawing segments here, so put your dots on the end. You want to put point B in between A and C. That's the very first thing I want you to do. For this answer? I don't know. I hadn't worked it out yet. It shouldn't be negative, though. If we're talking about the length of something, we shouldn't have negative numbers. Right. B is between A and C. That means A and C are the ends, and B is somewhere in between. Does it say in the middle? No, it just says in between. It could be in the middle, but it doesn't say that it has to be the middle. So I'm just going to put it somewhere in between. Is that what everybody else drew? Mm-hmm. What else does it tell me? What does it tell me about AC? AC has what length? 4x minus 12. So this is where we're going to label our picture. AC is the entire thing here. From end to end, right? This is also where some people get mad because they're like, I'm getting the geometry and I'm digging it, but now you're throwing in some algebra and I don't like that so much. Okay, that's what we have to do. What does it tell me about AB? It's just X. So let's label AB as X. And what does it say about BC? Okay. Are we ready? No. What's my long segment? AB, BC, or AC? AC. And what did they tell me that length was? 4x minus 12. Okay. And then my two smaller segments, AB and BC, we have a length of those two, right? Now, if I have x, that means I have to have an equation so I can solve it. Yes. What do you think? Segment addition says we can take our two small segments, right? And add them. What are my two small segments? AB and BC. Okay, so let's take a look. What is AB again? X. Okay, that's my one small. Plus, what's my other small segment? It's not one to write. Okay, and those two added together are going to equal my big segment, which is? There you go. Does everybody kind of see how that works? We took the small one, AB, which they told me was X. Then we took the other small one, BC, which they told me was 2x plus 3. And we set it equal to the large one, which they told me was 4x minus 12. Does everybody agree with that? I gotta do some algebra. I'm going to go basic. My equation is my fence. My equal sign is my fence, right? So what I want to do is I want to get my x on one side of the fence and I want to get my numbers without x on the other side. But before I do that, I want to look at each side of this equation. Okay, so I'm going to focus on this side only. Do I have some terms that have either both have variables or both don't have variables? Yes, those are my like terms. We need to combine those. How many x's is that? 1 plus 2 is going to give me 3x. Okay. Do I have anything that I can combine with that piece? No, so I'm just going to bring that down. Bring down my equal sign. Do I have any like terms over here? No. Now, to jump the fence, I have to do inverse operations, which means I have to do the opposite of what it is. I want to get my x's together I usually do that first. Okay, doesn't mean you have to do it first. What's my smaller x? 3x. So how would I take this 3x and get it over here with this 4? Subtract. Okay. Is jumping the fence by doing the opposite. Those now cancel. I'm going to bring that positive 3 down. What is 4x minus 3x? 1x. Do I have to put the 1 in front of it? No. And then I'm going to bring down that minus 12. And then I want the x to be by itself. So I need to get rid of what's next to my x now. 12. It's minus 12, so how do I make it jump? At 12. 3 plus 12 is 15. So therefore, x is going to equal 15. That was my first question, right? This is where we have to be careful with geometry because a lot of times they're going to ask you multiple questions. It says find x, which we just did. What else does it ask me to find? BC. How do I figure out how long BC is? Substitute it in, yes. So we know that AC, give me a different color. We know that AC is x, that's 15, correct? So to find BC, can I just take, and instead of x, could I put in that 15, plug it in, substitute, whatever you want to call it? What's 2 times 15? 30, and 30 plus 3 is 33. So in this case, I have 2 separate answers. X is 15, and BC is 33. We good? I want you to read that last question, and I want you to try to draw a picture to represent it. And again, it doesn't have to be like an artist drawing. You can just use lines to help you draw that. Okay. So, read what it says. Read a little paragraph. These are going to be the types of questions they're going to ask you to do stuff like on the EOC. They're going to give you a simple concept, but they're going to throw a paragraph and a half at you to read and understand before you can try to figure out how to do that question. So it says, Daryl is visiting the Space Needle in Seattle, Washington. He knows that the total height of the Space Needle is 605 feet. So everybody know what Space Needle is? It's just a vertical line. Vertical, it's a tower basically that you go up and look. So you can use just a vertical line to represent that Space Needle. How tall does it say that Space Needle is? 605. So draw yourself a vertical line. That's straight up and down. A line, yeah. We don't need to draw an artist's picture. We can just draw a line. So here's my observation, or my Space Needle. And it tells me that that is 605, right? From the bottom to the top. Then it says the distance from the ground to the observation deck. Okay, now the observation deck is going to be kind of up top. Let me draw that in green. So let's say your observation deck is here. So the distance from the ground to the observation deck is, we got to read this a couple of times. 10 feet more than 6 times the distance from the observation deck to the top. Okay, so let's read that again. 10 feet more than 6 times the distance from the observation deck to the top. Do we know anything about how far it is from the observation deck to the top? No. So when we don't know things, what do we call them? A variable. Any variable. X, right? So, whoops. From the top to the observation tower, we're going to call that X. We don't know what that is. I'm trying to keep it color-coded, too, to help, but I don't know if that's really working. So now let's think about that. 10 feet more than 6 times x is what we call the top part, right? How do I write 10 more than 6 times x? Either way. You're going to say 6x plus 10, and you said 10 plus 6x. Does it matter which way I write it? No. Okay. 10 more than 6 times that. Or 6x plus 10. Those are both the same thing. So now we have a picture. Now we need to we need to set up an equation. Very similar to what we just did on the last question, except for turn sideways this time. What are your two small pieces? X and 10 plus 6x. And so what do we want to do to those? Add them and set them equal to 605, yes. So we want to take our two small pieces. We want to take x, let me write this down, plus your 10 plus 6x, or 6x plus 10, however you wrote that. Two small pieces, add, and set it equal to the whole. What's the whole thing again? 605. So take that equation and solve it. Two small pieces. X plus the other small piece, 10 plus 6x, equals the whole thing. Why do they take these questions that could be so simple and make them so hard? Just because that's what they like to do to teach you the test. You do it to the other side. So you do it on this side. Remember what we talked about. If you need to, and this is going to be how you approach it from here is depending on your algebra skills. Okay, if you're strong in algebra, you can do it. If you're struggling in algebra, it's going to be a little bit more difficult. Okay, so I'm going to do it as easy as I think I can. Okay, there's my fence where the equal sign is. The first thing I want to do is combine like terms. What like terms do I have on that left side? X and 6x. That's going to give me a total of 7x. Okay. No more like terms anywhere that I can combine. Now I need to jump the fence. What am I going to move over with the 605? The 10. And I do that by subtracting. Yep. So that's going to be 7x equals, what is that, 595? And then what do I do? And so x is going to equal 85. Now here's my question. Is that what they asked me for? No. Okay, they asked me, x, remember, represents from the observation tower to the top. What did they ask me for? Observation tower to the bottom. So what do we have to do with that 85 now? A couple of different ways. Would it be okay if I just took the whole thing and subtracted the 85? Would it also be okay if I took it and plugged it into that? Either way, okay? So you can either take the whole thing and subtract 85, or you can do 10, you can do 10 plus 6 times 85. Those both will give you the same answer. $520. Okay. So another thing you have to be careful with is they'll ask you to solve a question, but then they're going to ask you for something else. So a lot of times you solve an equation, oh, I got an answer for X, I'm done. You have to be very careful because most of the time they're going to ask you to then take that answer and put it somewhere else to use it. Okay, so just be very careful. Anybody have any questions? All right, we're going to do more practice with this tomorrow, but I do have your homework for you. Okay? Like I told you, it's always worksheets, so I always have something printed for you. Most of these are relatively easy. Now, in questions 10 through 17, you're going to want to draw your picture to represent what it's telling you. And I'll show you on the board in just a second after I pass everything out. We'll talk about the picture for 10 through 17. All right, so I just want you to take a look. 10 through 17, it does not have a picture that goes with it. So what we're going to need to do is we're going to need to make sure we have that picture. It says you're finding the value of the variable and yz. It says if y is between x and z. So you're going to want to draw that out. Y is between x and z. Okay, so that's the picture that you're going to want to use for 10 through 17. And those questions are going to be just like what we did for this second to the last example up here. Okay, so you can kind of follow along with that, how you do that. Does that make sense? Everybody okay with that? All right. Then I'm done.